Hello friends, welcome to the part 3 of our talk on Bedforms. We'll be talking on tides and tidal bundles. A few terms to familiarize ourselves with. Tides refer to the rise and fall of water levels in the open ocean, and that's triggered by the combined effects of the gravitational pull exerted by the moon and the sun on our dear Earth. The rise in the water level is called a high tide, while the fall in water level is termed low tide. Now, the difference between the highest tide and the lowest tide is called the tidal range. Tidal ranges can be quite small, in which case we refer to such periods as neap tides, or they could be large, also called spring tides. Tidal currents are near-shore horizontal movements, and that's triggered by the vertical rise and fall of the ocean tides. And that can be either in the form of a tidal flood or a tidal ebb. Tidal floods are periods when the water level is, rising. That means it's moving towards the land away from the sea. On the flip side, the tidal ebbs are periods when the ocean water is falling. That means it's moving towards the sea, away from the land. Slack tides are very weak currents which occur between the tidal flood and ebb currents. Alright, a little bit about neap and spring tides and tidal bundles. Firstly, let's note that the words neap and spring as used here does not refer to the seasons. There are 2 neap and 2 spring tides in a month, and that is because it takes the moon 1 month to make a complete rotation around the Earth. During that 1 month cycle, the moon will be aligned with the sun twice and at 90 degrees to the sun twice. So the whole idea here is that each time the moon, the sun and the Earth are all aligned in a straight line, the Earth will experience the greatest gravitational pull. On the other hand, when the moon and the sun are at 90 degrees to the Earth, we record a lower gravitational pull. Some authors think that the word spring originated from the German word springen, which means to leap. Okay, so let's look at how this rotation thing happens in a 1 month cycle. So supposing on day 1, the sun, the moon, and Earth are all in a straight line, we're going to be having the largest combined gravity pull on the oceans, and that would be high tidal range or our first spring tide. So 7 days down the lane, the moon will have completed a 90-degree angle on its rotation course around the Earth, and that means by this time the sun and the moon are at 90 degrees to the Earth, which means a smaller gravitational pull on the oceans and a low tidal range. So this will be the first neap. And then 7 days again down the lane, we have a repetition of the straight line pattern, and that will be our second spring. And then we now have the second neap when the moon completes the last 90-degree lap. So overall, we're saying that each time the sun, the Earth, and the moon are all in a straight line, we have the strongest pull on the Earth, and then that means we have the spring tides. And then when the sun and the moon are at 90 degrees to the Earth, we have a smaller gravitational pull, and that will be the neap tides. The strength of the gravity pull on the Earth has direct impact on the transport or depositional velocity of sediments. This is a plot of sediment transport velocity with time for both neap and spring cycle. And what we see here is that in the neap tide, we record smaller flow velocity because that's when you have the lowest gravity pull on our ocean waters. And that results from the fact that the sun and the moon are at 90 degrees to the Earth. In spring tide, we record the greatest current velocity because by then the sun, the moon, and Earth are all aligned in a straight line, resulting in the greatest gravitational pull on the Earth. The section below shows a typical representation of the tidal bundles and their thicknesses for both neap tide and the spring tide. So we observe here that in the neap tidal bundles we record very small sand content or very small thickness in terms of sand content between the mud draped faucet plains. On the other hand, for the spring tidal bundles, we see much thicker sand beds or sand content between the mud draped faucet plains. This is an outcrop example of tidal bundles in cross-bedded sandstones. So if you focus on the red box in the upper left, it's a zoomed in section showing the spring tidal bundles, while the blue box in the bottom right is also zoomed in section of the neap bundle. So we notice again that the sand content between the faucet plains are better developed or are thicker for the spring bundles and thinner for the neap bundles. Thank you very much for your time. It's been a pleasure having you. Until next time, please do stay well.